Great, question 9. The matrix X is given by this. Show that the determinant of X is a squared minus 8a plus 15. Okay, this is just, we know how to find the determinant of a 3 by 3 matrix. This is one of those things that you have to go into your FP1 exam having practiced it, knowing that it's almost certain to come up at some point, and you can just do it. In this case, because that first column has a 0 in it, the calculation is slightly easier if we choose the first column to go with. It's not a big deal, but if we're going to do the determinant of that, I'm going to use the first column. I'm going to do A times the minor determinant. They gave you a bit of space, so I'm going to write this out to make it really clear what I'm doing. A times that minor determinant, A, 5, 2, 1. Well, I'm going to put minus 0 times 3 minus 2, 2, 1, even though I know that that's pointless, because that's going to be 0, plus 1 times that minor determinant, 3 minus 2, A, 5. Now I'm going to work those out, so that's A times A minus 10. This is just 0, because it's 0 times whatever that would give us, plus 1 times 15 minus minus 2a. So we have 15 minus 2a there. And if we pull things together now, we've got a squared minus 10a plus 15 plus 2a, which is what we were supposed to get. That's right, isn't it? A squared minus 8a plus 15. Great. Dead simple, 3 marks for doing that. You could have done it with any row or column, so lots of people did it with the top row, which is fair enough. You still work out the same thing and end up with the same answer at the end of it. Then it says, explain briefly why the equations that are given there do not have a unique solution, and determine whether these equations are consistent or inconsistent. Okay, well it's in the same question. It must have something to do with what we just worked out. And unique or not unique solutions, that's all about the determinant of a matrix, isn't it? So there must be that connection in there. You don't have to go into this much detail, but as we start thinking about those equations, they were, I'm just going to write them out so that I can see them here. These are the equations. 3y plus 5z is 5 and x plus 2y plus z is 2. Have I copied those right? Okay, and that leads us, that implies, if we turn that into a matrix form, that is 3, 3, minus 2, 0, 3, 5, 1, 2, 1, times x, y, z is 1, 5, 2. So that's what it looks like as a matrix. Remember that the unique solution stuff is all about the determinant. So that is the matrix A. Do we recognise the connection there? 3, 3 minus 2, 0, 3, 5, that's 0, A, 5, and then 1, 2, 1 on the bottom line. So that is A with little a being equal to 3. That's what we're working with. We've got an equation for the determinant. So the determinant of A is equal to a squared minus 8a plus 15. So that's 3 squared minus 8 times 3 plus 15. That is 9 minus 24 plus 15, which is 0. That being 0 tells us there are no unique solutions. So when it said explain briefly why there are no unique solutions for this, you had to show that the determinant of the matrix you were working out was equal to 0. That's it. You didn't have to work out the determinant all over again. And then it says, are the equations consistent or inconsistent? And there are a couple of ways that you can work this out. You can try and solve the equations. If you try to solve the equations, just remember for a moment because the determinant is 0, we can't use a matrix method to solve it. We can't find the inverse of this matrix and do it that way. So you have to try and solve it kind of simultaneous equations way. So you could try and do that. You could try and eliminate x or y or z, set up 2 equations and 2 unknowns and try and solve those. If you did that, you would find you end up with some true but not helpful statements, like 3 equals 3 or something like that. You'd end up with a consistent pair of equations. The other way of doing it is, can we show that the equations are multiples of each other? That one of the equations can be made by combining the other 2. And so I think my approach to this would be to start with to think, can I spot that? If I can't spot that, I'll try and solve them. And I looked at these equations and I thought that there are kind of lots of 3's going on here. If I multiply this equation by 3 and subtract this one, then that gives me the top equation. Can you see that? So if we call these equations 1, 2 and 3, if I do equation 3 times 3, and then I take away equation 2, that gives me 3x, take away nothing is 3x, 6y, take away 3y is 3y, 3z, take away 5z is minus 2, and 6, take away 5 is 1. That gives me equation 1. Therefore they are linearly dependent. So they are consistent. And the question just said, state whether they are consistent or inconsistent. That's all that we were looking for, some conclusion on those lines. Alternatively, if you hadn't spotted that, if I hadn't have quickly spotted that, I would have attempted to solve them, and I would have got some kind of true statement that didn't get me anywhere. Remember, if you attempt to solve them and you get a contradiction, then that tells you that they are inconsistent. So that's the way of showing that they're inconsistent. There we go. That's it. That was matrix maths.